ladies and gentlemen. So I'm not the person for standing here, but instead of Professor Richard Meadow, so I should be chair of this session. So at first, in this session, we are inviting three panelists. So first, I'd like to invite Dr. Brian Edward Hemphill. So please.
First of all, I'd like to start by thanking the organizers of the conference and Dr. Lashari for inviting my participation here. I come from quite a long ways away. I come to you all the way from Alaska. Today, I'm going to talk about, how do we get to? It's on. Okay. Today I'm going to talk about the enigmatic skeletons from Mohenjo-Daro. These skeletons have been the subject of considerable controversy for a number of years. I think we all know that during the course of excavations in the lower town by Marshall and Mackay, skeletal remains were recovered in non-mortuary contexts. These included 9 individuals from Block 10A in the DK area, 2 from Section G in the same area, as well as 6 individuals from a lane in the VS area, but perhaps most famous of all are the 14 individuals recovered from room 74 in the HR area. Various researchers have offered an array of explanation for these remains. Marshall suggested that they were the victims of plague, and this was repeated by Kennedy in 1984. Mackay suggested that they were victims of bandits from the late phase of occupation of the city. Perhaps most memorably was Wheeler, who interpreted these remains as signaling the demise of the city at the hands of Aryan invaders from Central Asia. Finally, Dale suggested that these remains post-dated the abandonment of the city, and its ruins were used as a place for the disposal of the dead. Unfortunately, the state of preservation of these remains is poor, and some were sub-adults at the time of death. Consequently, the crania of only 16 adults from Mohenjo-Daro could be compared to a battery of 1,463 adults from 29 prehistoric and living samples. These samples include 8 from the Russian steppe in green, 7 from East Asia in orange, 7 from West Central Asia in yellow, 3 from the Iranian plateau in magenta, and 3, plus of course Mohenjo-Daro, from the Indus Valley in blue. 8 craniometric variables comprise the data upon which comparisons are based. These include 2 measurements of the neurocranial vault and 6 measurements of the face. Although this battery of measurements cannot be considered ideal, it has proven useful in previous studies, and it permits inclusion of a large proportion of less well-preserved individuals. Efforts to identify the biological affinities of a few individuals separated in time and space from potential source populations is an involved statistical endeavor. Assessment of biodistance is undertaken with 4 statistical protocols. These include principal components analysis, canonical variance analysis, neighbor joining cluster analysis, and multidimensional scaling. If Marshall is correct that these individuals represent residents of the city who perished from disease, then they ought to share closest affinities to their contemporary from the period 3 cemetery at Harappa, followed by secondary affinities to individuals from Cemetery H and from the Gandharan Culture Cemetery at Timurgara. If, however, Mackay is correct that these individuals were late period residents of the city who perished at the hands of bandits, then one would expect that they ought to share closest affinities to their contemporaries from Cemetery H and Timurgara. If Wheeler is correct that these remains reflect the appearance of Aryan invaders at whose hands the cities fell, there are 3 possibilities. If these individuals were the victims of these invaders, then their expected affinities should be the same as for Marshall's model. If, however, they were the remains of the invaders themselves, then they ought to share closest affinities to their alleged source population, either in the inhabitants of the urban centers of the BMAC in Bactria and Margiana, or horse-mounted nomads of the Russo-Kazakh steppe. Finally, if Dales is correct that these are the remains of itinerant squatters who used the abandoned portions of the city for disposal of their dead, then these individuals may bear no affinities to any of the other samples included in this analysis. The first statistical protocol employs a principal component analysis of sample means for the 8 variables. All components with eigenvectors greater than 1 were retained. This resulted in 3 components that combined to account for 75.4% of the variance across sample means. A plot of group centroids for these components yields a confusing pattern. Most, but not all, of the step samples occupy the lower right over there. The 2 samples from Tepe Hisar in magenta are divided, and the 4 Indus Valley samples are spread out across the entire array, with Mohenjo-Daro occupying an extremely isolated position in the left side. An inspection of the data reveals 3 problems with using group means as the operational taxonomic unit, or OTU. First, preservation tends to be poor, and missing data occur non-randomly. This means that use of group means introduces systemic bias, and this bias is greatest for those samples with the greatest proportion of missing data. Second, the use of group means ignores within-group variance. Consequently, biodistances are based on between sample variance that may have little to no relationship to the actual variation in head and face shape among individuals. Finally, use of group means assumes that all variables have equal variance across samples and that all samples are equally variable. Examination of the data reveals marked differences in preservational quality, with completeness ranging from a high of 80% of individuals from Tepe Hisar, Tibet, and Yambulak to a low of less than 20% for Kuzali and Muzali. In addition, Levine's test reveals marked heterogeneity of variance across samples, as well as between variance within samples. Such results suggest that the individual represents a better operational taxonomic unit than the sample mean. However, use of individual-based data requires that each individual is represented by a complete set of data. EM estimation was used to impute missing data. Missing data was imputed for no more than 3 variables per individual. EM estimation improved the proportion of individuals represented by complete data from 55% to nearly 85%. An examination of the descriptive statistics before and after data estimation shows very little change in mean values, a slight reduction in standard deviation, and a marked reduction in variance homogeneity. Now, principal components analysis seeks orthogonal vectors that maximize within sample variance, which, when individuals serve as the operational taxonomic unit, are counterproductive for identifying patterns of intergroup similarities and differences. In addition, principal components analysis employs a pooled variance-covariance matrix without regard for differences in sample size or variance heterogeneity. Such qualities limit its effectiveness when dealing with samples that differ with regard to within-group variance. A better approach is canonical variance analysis, which seeks to maximize differences between samples while minimizing differences among individuals within samples. In addition, canonical variance analysis permit the variance-covariance matrix to be calculated on the basis of within-group variance when heterogeneity of variance is an issue, as it is in this case. In the second phase, canonical variance analysis was undertaken with individuals as the operational taxonomic unit and with separate within-group variance. Canonical variance yield 8 axes that account for the entirety of the variance. The first 3 account for 75.1% and were plotted into 3-dimensional space. The first axis draws a clear separation between samples from Tibet, Hainan, and Uighur from all others. The second separates steppe samples in the foreground from West Central Asian samples in the background. The third axis separates Indus Valley samples with high scores from steppe samples with low scores. Overall, there's a pretty good regional differentiation of samples, but there are a few notable exceptions. Shahari Sokta, SHS, and Tigrovaya Balka Makoni Moor, TMM, are flipped around, with the former showing closer affinity to steppe samples and the latter with closer affinities to Iranian samples. The Xinjiang sample from Kroran shows closer affinities to the West Central Asian samples, while the West Central Asian sample from Karatepe shows closest affinities to the two samples from Tepe-Hisar. Apart from the sample from Cemetery H, which is identified as possessing affinities to the two samples from Xinjiang, Karagul and Yan Bulak, the Indus Valley samples stand out as unique, and of them, Mohenjo-Daro stands out as the most unique of all. Now, a limitation of plotting the first three canonical axes is that the percentage of variation is limited to those three axes, in this case, 75%. One way around this is to calculate Mahalanobis generalized distances between sample pairs with all 8 canonical axes, and thereby obtain a composite estimate of biodistances with neighbor joining cluster analysis. In this way, the entirety of the variance is accounted for. Neighbor joining cluster analysis identifies most East Asian samples and the steppe samples as the most divergent. They occupy peripheral positions on the left and the right sides of the array, respectively. There are, however, 3 exceptions. These include the samples from Kroran, KOR, and Yan Bulak, YAN, from Xinjiang, in which the former shows affinities to the BMAC samples from Bactria, while the latter is identified as showing closest affinity to the Indus Valley samples from Cemetery H and the Period 3 cemetery at Harappa. Mohenjo-Daro is identified as possessing closest affinities to other Indus Valley samples, but these affinities are not close, the most proximate being Timur-Gara. Now, while neighbor joining cluster analysis does permit the totality of variance among individuals to serve as the basis of assessment of intergroup biodistance, it is biased towards those pairwise differences that account for the greatest separation between samples. Often, this is a highly desirable quality when seeking to detect large-scale differences, such as those occurring between individuals of different species. But when microevolutionary differences, such as those within and between members of regional populations, are of interest, pairwise contrasts that contribute modestly to the overall variance assume greater explanatory importance. Multidimensional scaling is an approach that allows greater parity in pairwise participation for depiction of intergroup differences. The diagonal matrix of Mahalanobis pairwise differences was submitted to multidimensional scaling, and a solution that accounts for 94.7% of the variance was obtained. The resulting plot yields a pattern of regionality. Steppe samples are on the left, East Asian samples in the right foreground, Indus Valley samples the center foreground, and West Central Asian samples in the upper right. Again, there are a few notable exceptions. Tigrovaya Balka Makoni Moor, TMM, is separated from the other steppe samples with closest affinities to the sample from Shahari Sokta, SHS, which is separated from the 2 Tepe-Hisar samples. Among the West Central Asians, there is a separation between those from Margiana on the left and those from Bactria on the right. The earlier samples from Margiana have close affinities to the samples from Tepe-Hisar, while the later Bactrian samples are identified as possessing affinities to 3 samples from Xinjiang, which are clearly separated from the other East Asian samples. The 4 Indus Valley samples show closest affinities to one another, but these affinities are not close. Instead, both Timur-Gara and Mohenjo-Daro occupy isolated positions with no affinities to one another or to any of the other groups included in this analysis. Is Marshall correct? Are the remains recovered from Mohenjo-Daro residents of the city who perished from disease? No. None of the analyses identify especially close affinities between these individuals and their alleged contemporaries from the period 3 cemetery at Harappa. Is Mackay correct that the remains are of late period city residents who were dispatched by bandits? Again, no. These results show no particular affinities to the remains recovered from Cemetery H. Was Wheeler correct? Do these remains reflect Indo-Aryan invaders from Central Asia whose presence led to the collapse of the city? Once again, no. None of the three possible scenarios, as local victims, as invaders from the BMAC urban centers, or as invaders from the Russo-Kazakh steppe, are supported by the patterns of phonetic affinities of the Mohenjo-Daro remains. Is Dales correct? That the remains are those of perhaps semi-nomadic squatters who dispose of their dead in parts of the abandoned city? Yes, for these individuals do not appear to be related to any of the other samples and may in fact represent herders who were intrusive into the local population of Mohenjo-Daro. Overall, this craniometric analysis suggests the Bronze and early Iron Age period represented by the prehistoric samples included here was an era of general regional continuity with some porosity and some internal substructure. The steppe samples stand apart as biologically unique, and among them, the Afanasyevo samples consistently show close affinities to one another, while affinities among the Andranovo samples are more variable. The Central Asian samples claimed to be steppe affiliated very markedly in their affinities to Andranovo and Afanasyevo steppe samples. Kokcha 3 appears fully steppe in its affinities. Samtavro B does not. And Tigrovaya Balka Makoni Moor occupies a shared intermediate position with Shahari Sokta, suggestive of reciprocal gene flow between them. East Asian samples are divided between Hainan, Tibet, and Nepal on one hand, versus the samples from Xinjiang, with the most of the latter possessing affinities to BMAC samples from Bactria. Samples from West Central Asia are also divided, in this case, between those from Margiana, which show affinities to Tepe Hisar, and those from Bactria that share affinities with 3 of the 4 samples from Xinjiang. Indus Valley samples share closest affinities to one another, but these affinities are markedly diffuse, inconsistent, and volatile. As such, it would appear that different, only minimally related populations are being sampled. Are we looking at a situation in which the skeletons found sprawled in the streets of Mohenjo-Daro are but conservative locals, or are they reflective of intruders not related to the urban population? Well, numerous studies have shown that during the processes of urbanization, there are 3 general reactions that take place. The first is integration. What we find is that those cultural markers of ethnicity tend to decrease over time as individuals give up their separate ethnic